Complements and conditional probability. Now let's talk about complements first. So we're going to be finding the probability of some event occurring at least once. And so the way we're going to do that is we're going to think backwards. Backwards means complement. And so if at least one has the same meaning as one or more. So if you want to see something algebraically, what that might actually represent, one or more, if I use x, it would be something like this. But we're not going to think of it that way. We're going to think of it backwards. And so you have the complement of at least one, which is one or more. Well, if you think about what's not one or more, that means you get 0 or no occurrences. And the notation we use for a complement is like if A is the event of at least one of some event happening, then A bar is none. And so the way we do that is to find at least probability. P means probability. To find the probability of at least one, we do 1 minus probability of none. The reason why it's 1 minus is because the probability of any event A, the highest answer can be is a 1, and the lowest it can be is a 0. So let's look at an example. I'm going to do some typing. Probably easier to understand or to read with this example. So we're going to say that Square Trade, whoever that is, found that 6% of damaged iPads were damaged by bags and backpacks. If 8 damaged iPads are randomly selected, find the probability of getting at least one that was damaged. So, probability of at least one damage in a bag or backpack. That's the same as 1 minus the probability of none damaged in a bag, backpack. However, 6% were damaged, so we're going to think about actually the ones that were damaged. So if none were damaged in a bag or backpack, that means that they were damaged by something else other than in a bag or backpack. And that probability is 1 minus, well, that's what we got to think about. So let's think about this. So if there's 6% probability or chance of being damaged by bags or backpacks, that means that there's a 94% damage by something else. %, damaged by something else. And so, what that means is, and 94%, we won't use a decimal. So that's actually a probability. Damaged by something else. And how many of them were there? There were 8. So, I'm going to do it like this. So for the first one, second one, third one, fourth one, fifth one, sixth one, seventh one, eighth one. Probability that the first one was damaged by something else is 0.94. And the second one is also 0.94. And so is the third one and the fourth one. In fact, all 8 of them have the same probability of being damaged by something else other than a bag or backpack. And there's a fundamental accounting principle that you may have already studied somewhere else, hopefully this class, that says that if you have these, you want the first one damaged and the second one was damaged and this is all multiplication. Now that's a lot of writing. Now that's just 8. So what we're actually going to do is we're going to do it like this. So the probability of at least one is equal to 1 minus probability of, I'm going to just say, damaged by something else. and those something else's have a 94% probability. And so there's 8 of them. Keep that in mind. There's 8 total. 8 damaged iPads. So it's going to be 1 minus. Now, I really don't want to write all that out again, so there's a shortcut way, and that's using exponents. 0.94 raised to the 8th power. That's how you really want to look at it. It looks like a y, doesn't it? So let's erase that. Let's make it a 4. So that's how you want to think of it. You're thinking backwards. So if it has a 6% chance of being damaged by a bag of backpacks, that means it has a 94% chance of being damaged by something else. Or by something else. I should use the word by there instead of in. And how many of them were there? There were 8. And they were all 8 were damaged, so it's 94% chance for each. So that's why I'm using the exponent. And so what we're going to do is just take out our calculator and type that in, just as it is. 1 minus 0.94 raised to the 8th. Enter. And we get 0.39, if I go to 4 decimal places, 0.04. And that's how you do a complement problem like these. Backward, not complement, but and at least using complements, which is thinking backwards. Now, conditional probabilities are a little bit different. These are based on what's the probability of something given something else. And so, to give you an example, what's the probability of drawing an ace from a standard deck of cards given a red card? So what you want to do is, you want to start with the given. That's actually going to be your denominator. Your denominator. And so, these are all your red cards down here. And there's actually 13 per suit. So there's 26 total. And of those 26, and that's going to be your denominator, by the way. So, probability of an ace given a red card. On the bottom we have our 26. Out of those 26, how many of them are aces? 2 of them. So that probability is 2 over 26, which reduces down to 1 over 13. And that's how you do givens. The given is actually on the bottom. Now, there actually is a formula. I'm using the word actually quite a bit. And that formula is this right here. Anytime you see this line, this represents the word given. So what's probability of A given B? And so this part is the real formula. Probability of A and B divided by the probability of B. So like in this example, probability of ace and a red card. So let me do it like this. A given red. Using the formula would be ace and red. That's actually not correct, because it should be like that. It will be divided by probability of a red card. This is a long way. So what's the probability of ace and a red? In this case, you have to look at all 52 cards. And how many of those 52 cards are both ace and red? Well, that'd be 2 of them. The probability of red, if you take a look at it, there's 52 total and 26 of them are red. Now, see, that looks kind of ugly, kind of bad. It's not difficult to do, because the way you can do it is you can rewrite it like this. There are all kinds of ways. I'm actually showing you probably the safest way. You can rewrite it like this, and if you remember fractions, you multiply by the reciprocal, and these cancel out, and that reduces. 2 goes in 2 once, 2 goes in 26 13 times. And that's the way to do it, the formula. But as you can tell, this way is way easier, the original way I did it. So by all means, that's the reason why I showed it that way first. It's way easier, so I highly recommend that approach. So my approach actually uses these n's. N means number. So it's kind of just a way to think of it. An easier way to think of it. Number of something. So let me show you what I'm talking about. So here we have this information in the table. We want to select a graduate who was offered between $40,001 and $45,000. What's the probability the student has a degree in the health fields? Well, there's actually a given there. So I'm going to type that out because it makes it a little bit easier to see. So here's actually the problem. Probability health field degree given were offered between $40,001 and $45,000. That's actually what's being asked. Do you see that? The real question is, what is the probability a student has a degree in the health fields? That's the real question. But there's a stipulation. That stipulation, or that given, they were offered between $40,001 and $45,000. That's what I have here. So you want to start with the given. This is your denominator. So how many are there between 40,001 and 45,001? So if you look here, it's always nice when you have this column and this row. That's a column and this row. When you already have the totals for you, that's just one less work, one less step you have to do. If these totals weren't given, I'd define this 15. I would take 1 plus 2 plus 1 plus 3 plus 8, and I would get that 15. 1, 3, 4, 7, 15. So that takes away some of the work. So what's probably a health field given that were offered between 40,001 and 45,001? So if I look here, that's the given, and the total I have is 15. So that's my denominator. And of those 15, and that's how you think of it, of the 15, how many are in the health field? And that's going to be your numerator. So this is your denominator. This is your numerator. How many are in the health field? This right here. See that? Health fields. Of those 15, 3 were in the health fields. And that reduces down to 1 over 5 because 3 goes in 3 once, 3 goes in 15 5 times. If you don't know if you've watched the other videos I may have shown you, but if you do 3 divided by 15 in the graphing calculator and hit math enter, it will reduce for you. And I do believe that's the last example. And as always, if you have any questions, please let me know.